My name is Yuxing Wang, and I'm a PhD student working on marine heatwave research, so I will be the chair of today's seminar. I'd like to begin by the acknowledgement of country. I acknowledge that I am joining this meeting from the lands of Palawa Pakana people. I also acknowledge the traditional custodians of the various lands on which you all join from today. I pay my respect to elders past, present, and emerging. Now I would like to extend a welcome to Dr. Claire Spillmann as today's speaker. So Claire is a principal research scientist and leads the seasonal and marine applications teams in research at Bureau of Methodology. Her current research is focused on seasonal forecasting for marine applications, particularly marine heatwave prediction, coastal hazards and reefs, aquaculture, and fisheries management. She's also a associate investigator in CLEX and a member of the IMO Science and Technology Advisory Committee and the Australian representative on WMO Subseasonal to Seasonal Project Steering Committee. Claire is frequently called on to give media interviews, public webinars, and contribute to government and industry. And today, Claire will give us a talk on her current research entitled Predicting Ocean Extremes at Subseasonal to Seasonal Timescale for Operational Decision Support. And as usual, we'll have the talk now and with time for questions at the end, and then the ECR session at 11 o'clock, which is on I think a separate Zoom link. And now I'll hand it over to you, Claire, to begin your talk. Thanks.
Thanks, Yushin. I'll just share my screen. All right, can you see that? That coming through now?
Oh, we can see that.
All right. Great. So I'm across two screens, so it's going to look like I'm not talking to you, but I'm just going to go between the two. So thanks for the invitation to speak today. So when Neil Holbrook originally asked me, I was thinking about what I could talk about today. And I think I've had a lot of conversations with CLEX knowledge brokers over the years around getting your research out, having impact and value, and talking to customers. So that's something that's very close to my heart. So this talk is not so much the nitty-gritty of the research, it's more around developing or getting your science out to users and customers, so having real-world impact. So I'll kick it off. This work has all been done with partners at CSIRO, so Alistair Hobday, Jason Hartog and Kathy McGuinness, as well as colleagues at the Bureau, so Grant Smith and Wendy Sharples, but others as well in my team. All right, we'll get this moving. Okay, so I'd like to start with the big picture. So in terms of Australia's marine resources, so this is the motivation for doing this work. And so I guess there's a few different aspects to take into account when we're talking around marine resources. So the Australian EEZ is the third largest fishing zone in the world, and the gross value of the fisheries and aquaculture is estimated around $3.6 billion a year. So that's a huge amount of money, and it employs a lot of people. That's wild fisheries. Then if we look at aquaculture as well, there's a lot of aquaculture offshore, in estuarine areas, and also on land. You combine that with our national parks. So this is from Parks Australia, and the different colours show the different national marine parks that we've got around the coastline. Not forgetting the Great Barrier Reef, which it alone contributes over almost $6.5 billion to your city. So there's a lot of jobs, there's a lot of value in our environmental resources, both from the general public's perception of that value to fisheries and aquaculture. Climate change, this is a really nice graphic from IPCC, is a triple threat for the ocean. So with looking at forecasts going ahead or projections, the oceans are to be warmer with less oxygen and more acidic. So the focuses of my research and of this talk today is around looking at sea level and also warmer oceans and how we can prepare users for a changing climate in the ocean. So this is data from NOAA for sea surface temperatures around Australia since 1900. And you can see that 2022 was the warmest on record for Australia as a whole. So you can see this warming trend here. Everything here is red, which means it's warmer than the long-term average, which is the baseline is 1961 to 1990. So given that the recent decade is the warmest on record, this is a pretty cool baseline to be using. So the World Met Organization and Met services around the world are looking to update this baseline to more recent 30 years, but it still gives you the idea here that the oceans are warming, or get a good picture of that. If we then look forward under climate change, these are projections in IPCC. So you can see, I'm sure you're all familiar with these plots. Looking in the top panel, that's showing global mean surface temperature. So that's your background warming. And then overlaid marine heat waves. So these are the extreme events. So you have background warming, but then it's that variability around that background that can have the greatest impacts on industries and resources. So the two ocean extremes I'm going to talk about today and forecast products that we've developed for them. The first is marine heat waves, which I'm sure most people here are very familiar with. So this is a plot here showing some major events. It's from the marineheatwaves.org webpage. And then the second extreme we're going to look at are ocean hazards. So, coastal hazards. So these are due to extreme water levels, and they can be a combination of different factors driving those. So sea level rise, that's your background contribution. Overlaid over that is high tides, storm surge, wind and waves. So, and those will change with climate change as well. So the frequency, so how often that areas get hit by marine heat waves or coastal hazards, the intensity or severity, and the magnitude of all of these are projected to increase under climate change. So if we take those hazards or marine ocean extremes, what are the impacts? And there's a cascade of impacts. So first off, we have the impacts on the actual system itself. So these can be the direct impacts on the ecosystem, for example. So coral bleaching, that's a pretty obvious signal of high ocean temperatures. Changes in fish abundance. Migration pathways can change, so fish aren't found where they would normally be found. Toxic algal blooms, which have impacts for human health as well as marine life. Increased disease risk. For example, warm ocean temperatures can lead to coral disease in winter. And then there's also coastal inundation from high water levels and coastal erosion. These system impacts, is that going to work? Then lead to operational impacts. So these can then bring about things like fishery closures. So regulators will close a fishery if the system's under high stress, or there's been recent fish kills, for example, or toxic algal blooms because people can't eat the shellfish, for example. There's damage to property from high water levels, loss of access, so people can't get in or out of the coastal zone if there's high water levels. They can't take their crop off or harvest their salmon, for example. There's biodiversity loss, so impacts on the ecosystem and food chain. And there's things like also beach closures, which will affect the general public, not just the marine operators. These then have impacts on the actual communities that then live in the coastal zone and rely on those industries. So it's reduced profitability, increased costs because you need to mitigate the impacts of these coastal hazards, and that then turns decreases the resilience of the community and the industry. A worst case scenario, it's loss of life and impacts on human health. Another consideration is food security. So perhaps not so much in Australia, but in other areas such as Pacific Islands, where they rely very heavily on their local fisheries. If they are strongly impacted by ocean hazards such as marine heat wave, that can have severe ramifications for food security. That then leads to illegal fishing, which can be a concern for defence, for example. So how can marine users respond? So this is where sub-seasonal to seasonal forecasting comes in. So when I say sub-seasonal, I'm meaning sort of beyond a weather forecast, so 1 week out to around 6 weeks, out to seasonal, so 6 months in terms of the model that we use. So these forecasts can provide advanced warning of these ocean conditions and then inform management plans and responses. So this is an example of a proactive management, rather than just sitting there and going, all right, my water is really warm in my salmon pens. I need to do something now, today. That's very reactive, and that's what you get at the weather forecast timescale. So that's not long enough to evacuate a town because the water levels are going to be really high, or it's not long enough to be able to harvest your shellfish and get them out before conditions are ripe for an algal bloom. At the longer term, we've got climate projections. So this informs policy, planning, releases of leases, for example, for aquaculture, but it doesn't inform the decisions that people need to make right now in the coast and on the water. To that end, management responses, or how much people can actually do with the forecast information, influenced by the agility and also their risk appetite. And I'll touch on these later in the talk. So that S2S forecast time window, so 1 week to 6 months, provides time for a manager or an agency to respond and implement strategies to mitigate the impacts. So this part, I'm going to talk about actual forecasting, and then what makes useful. We want useful forecasts. We want usable forecasts that customers can understand and know what to do with. And we want them used. There is no point developing forecasts that I think, oh, these look great. These will be super helpful for fishermen or fishers, but then they don't use them. So I will go through a little bit on the background of the forecasting, and then how do we get our forecast information out to people so they can understand it and so they can use it. So what is subseasonal seasonal forecasting? These are, when I'm saying that, we're talking about dynamic climate models. So they provide information from 1 week out to months into the future. How far out they go will depend on the model that's being used, but the majority around the world are around 6, maybe 12 months into the future. As then predictability of the processes is decreased and the accuracy of your forecast is reduced. So dynamical models incorporate climate change signals, which is a big advantage over statistical model. So in theory, they can predict unprecedented events, which is what we're looking at on climate change. Our baseline is changing, whereas statistical models are just using information that's happened in the past. So the models we use are coupled ocean, atmosphere, land, and sea ice models. All the different models talk to each other, so what's happening in the ocean then affects what's happening in the atmospheric model. The grid resolutions for these kind of models, so they're 3D down to the ocean floor and up to multiple layers in the atmosphere, are around 25 kilometre to 60 kilometre. So they're much coarser than a weather model because you just can't predict processes at a finer scale when you're talking months into the future, but they are much finer than a climate change projection. So the model we Bureau is Access S2, so the Australian Community Climate Earth System Simulator, the seasonal version. So this is our operational system. It runs every day. It's global. Obviously, the Bureau is serving the Australian public, so a lot of our forecast products are Australian only. But then we also produce global forecasts to provide context and information around what's driving Australian climate, for example, what's happening with ENSO. So the model was developed in collaboration with the UK Met Office, CSIRO and universities, and it's been, this current version, Access S2, has been operational since October 2021. And the schematic here on the right, we've got, just shows kind of an overview of how the models are set up. So we've got data assimilation. It takes all the current obs that we've got, puts them together to give the best guess estimate of the initial conditions, so the current state. I saw Craig Bishop on here before, so you want to talk data assimilation, he's the person to go talk to. He was involved in developing the system. And then it goes, that information is fed into the coupled climate model. And as I said, we've got an atmosphere, ocean, sea ice and land model, and then we produce an ensemble of forecasts. So this gives a range of outcomes. We have a hindcast, which we run. So we run the model retrospectively for 40 years. We use that information to produce our climatology, to bias correct our forecasts, and to assess our skill. We have our real-time system, which is running today and providing the real-time forecasts. And And if you're interested in more details on the actual model, I'll point you to the Wed et al. 2022 paper, which is published in JSHES, which goes through each part and how it's assessed and put together. So this is a focus on marine users today. So the ocean model, 5K by, and the total, so the course which would be the 1 metre, and no line thickness just too thick. The ocean data, and as we've got a hindcast data set the last 4 odd to 6 months. Information or will make a months. We have 99 memorable, which we run the model 99 times the probable forecast. Sorry, and then we have operational sea surface temperature and sea level forecasts. Obviously, there's a whole atmospheric part, but I'm going to focus on the. And on the right is an animation from my team showing the surface temperature at native resolution around Australia. Okay, so what are the benefits of using these forecasts? So I touched on this earlier, but if you're talking to an industry or a customer, the benefits can be, we tend to focus on the negative if we're talking about marine heat waves, but for some industries or and some locations, warmer waters could be good. It means the fish grow faster to a point, and maybe their profits will be higher. So the idea is using the forecast to support decision making is that you can reduce costs in a poor season. So maybe you don't put all your spat out because you know it's going to be a poor year. Maybe you buy a different license when your fishing license. You think, well, there's not going to be much tuna around because the ocean conditions are X. So you can reduce your costs. Or you can increase your profits in what's going to be a good season. Maybe there isn't going to be any marine heat waves, or maybe it's going to be a little bit warmer, which I know is good for the species I want to target. And so the idea is it can extend the time an industry can operate in a location as the environmental suitability declines under climate change. So it just means that if you can reduce your costs, increase your profits, you can stay in that location for longer. And that's really important, particularly for coastal communities that rely on those local marine industries. But to do this, you need to know who's making the decision. What are they doing with the forecast? What kind of decisions are they making? How are they going to use them? There is no point doing that in a vacuum and creating a forecast for a particular location or a particular hazard if you don't know what people will do with it. So these are some of the questions that we've had with over the years with various project groups and working groups and customer interviews. It's like, what management decisions do you make? When do you make them? Like, is winter the time that you make your decisions? That's when I buy my fishing license. That's when I put my spat out into my pens. That's when I allocate all my resources to reef monitoring, for example. Who makes that decision? Who do I need to be talking to? I could talk to the overseas owner of this big prawn farm, but they're not actually making any of the decisions. So I need to talk to the farm manager in that case. So who is making the decisions and when? What do you need in a forecast? What do you actually need to know? And how and when do you need it? So we worked with Queensland prawn farms a few years back. One guy we needed to fax the forecast to. He was really old school, but that's fine. We would never have known that if we didn't actually go and speak to him. And when do you need it? So how far ahead do you need to know that information? And a really interesting follow-up that can be tricky to tease out is like, since you had a forecast, did you actually change your decision? And what did you do differently? So that is that's often the million-dollar question. It can be very hard to tease that out, particularly if there's commercial in confidence arrangements. So you've spoken to your customers, you have an idea of what they want and how they'll use that information. So when are S2S forecasts going to be useful? So their usefulness depends on when they make that decision. They make it 12 months ahead and your forecast is only accurate out to 3 or 4 months, it's not going to be useful. What period do they need that information for? Is summer their key time that they need to know that information? And also, how accurate does the forecast need to be? And that's always a fun conversation because often people will say, nah, if you can't tell me with 100% accuracy, I'm not making any business decisions. And you say, well, I could have told you last year that you had a 60% chance of a marine heat wave. Would you have changed your mind, or would you have changed your practice last year? Oh, well, if I had known that, I would have done a few things. So it really depends on what levers those industries or managers can pull, and what their risk appetite is. And this is it's a long-term relationship exercise. It's not, here's a forecast, see you later. It's about working with them, understanding the decisions. We would never advise on what decision to make. It's always around the climate information and talking about how accurate it is and the likelihood of an event. And along with that, verification is absolutely critical. So you need to know how good your forecast is before you can take it to a customer and say, look, I've got a forecast for rain or drought or marine heat waves. Then you need to be able to communicate that. And so I think that's a really important part, is to be able to talk about your forecast product, why it is useful, and then how good is it and what does that mean? An accuracy of a forecast is not the same as a probability of an event happening. And often people conflate those. So the better you can communicate your skill in your forecast product, the more likely there is for forecast uptake. And that's when your forecast, research, your science actually starts making a difference. So I love this picture here. So just to underline that, the importance of doing this in collaboration with the agency or the customer or the industry or whoever you're developing your work and science for is, it does not matter how accurate it is. It could be 100% perfect, but if it doesn't provide useful information, is not given to users when they need it, they don't understand it, or it can't help make a decision, it has little value. And I love this picture here, which is Randy Watkins, just showing, you know, this is the path that was built, but nobody uses it. They just walk straight across. That's that's actually what the users want. So I think that's important to bear in mind. And this is a research, what was made, customer and fortune, and then this is actually wanted in the, so it's a dialogue and a conversation with people using your work. So this shows the benefits of an end-to-end connected approach. And so granted, I guess a lot of people on this call are probably in the underpinning science stage of this process, at least at this part of your career. So this is where you're doing the research, you're writing the papers, you're working out, you know, the accuracy or the what's driving the skill in the model, for example. But that's part of a bigger picture. So then when we have the forecast development and delivery, so getting those forecasts out to people, interfacing with users and industry, and then also extension and training. So my team is involved in each of these 4 components of the approach at the Bureau. Training is a really critical point as well. So that's building capacity in the industry or with the managers themselves so that they can then take that and go and talk to their shareholders or stakeholders. So it doesn't always need to be the Bureau or CSIRO, for example, going out and talking. So this is really critical. All right, so a great forecast. What can people do with them? So the first one is managers can use it to plan their operational activities. So that might be when they harvest, when they put their spat out, when they survey, if we're talking conservation, when they might do their planting perhaps. information can also be put into downstream models. So people can use subseasonal, seasonal information in, say, crop models, for example, or yield models. They might, other ones are habitat distribution models. Where are the tuna going to be this year? So that's for a regulatory approach, for example. You can downscale that information to station or farm sites if you've got the right data available. Provides an early window to put in those strategies to mitigate the risks. You can use probabilistic forecast information in risk assessments, depending on what you're looking at. And the other use that a lot of customers have for these forecasts is briefing government, briefing stakeholders. Department of Environment want to know what's going on this summer, for example. And also the general public, if we're talking, say, harmful algal blooms, for example. So these are some of the actual decisions that people make using this forecast information. So if you're a reef manager, it might be, where do we target our resources? The Great Barrier Reef, for example, is over 2,300 k's long. The authority can't cover everything. So if we know there's going to be a high chance of marine heat waves in the north, they're going to do some baseline monitoring before the summer and then aerial surveys during the summer. Will our fish stocks be further south this year? So from the Australian Fisheries Management Authority, it might be we need some observers on vessels south of this particular latitude. If you're coming out of Port Lincoln to go and catch tuna across the Bight, it might be, when do we leave port? Do we need extra staff? Do we need basically all hands on deck this summer because there's lots of stuff going on and we need to manage things really closely? Is it going to be a good year? We could increase our stock. Can we put more salmon out this year? Or do we need to decrease them to reduce the other stresses on our animals? Do we need to pull them out early? Or from a defence point of view, will there be food security concerns? So they're just some of the examples. And so to develop these kind of products and to work with customers, you need strong industry engagement. And so this is these are some of the examples over the last 15 or so years our team have worked with. So a lot with fisheries, aquaculture, defence. We're looking at marine insurance at the moment with partners in the US and coral reefs. The two that I'll talk more about today around marine heatwave and coastal sea level. So you need that partnership with industry. They need to be able to trust that you're doing something useful for them, and you need to understand what they need. All right, so moving on to marine heat waves. So I was thinking about how this work kind of evolved over the last few years. So what happened initially when I first started at the Bureau, so I could talk about more about that at 11 o'clock with the ECRs if they're interested, is we were working with the Great Barrier Reef Marine Park Authority. And so we knew coral bleaching is a product, well, is driven by ocean temperatures, so high ocean temperatures. Basically, a stress response for corals. They lose their symbiotic algae and then expose their white skeletons. So, and then the longer that stress is around, or the more severe it is and more frequent it is, the more chance there is of mortality. And you can see here, just this schematic here, is that you can have healthy coral over the days to weeks, ends up being bleached where they expel the symbiotic algae. And over days to weeks, that can result in dead coral. And there's no coming back from that. Coral is bleached, it can recover, but it's much slower process than it is visual bleaching. So the question was, could we be using our seasonal forecast that the Bureau was producing, this is back in 2009, to predict the ocean conditions to help inform the Great Barrier Reef Marine Park Authority about what the summer was going to look like? So in short, the answer was yes, and that led to the development of the first operational coral bleaching risk forecast service in the world, and with the main focus being the Great Barrier Reef and the Coral Sea. So we produced sea surface temperature, thermal stress, and probabilistic forecasts out to 6 months, and also provided forecast skill. So those products were heavily used by the Marine Park Authority through the summers. They kept an eye on them during the winter as well, because there was a risk of coral disease with a warm winter, but summertime was the main main focus for the Reef Authority. Once Access S came online in 2018 and replaced POAMA, which was its predecessor, we expanded to all Australian waters. So this is an operational public-facing service. There's a link there if anyone wants to go and have a look. And then the science behind those products and how they were put together and developed and verified are in these papers here. So this top one here, if you can see my cursor, this is the latest forecast showing sea surface temperatures from October. I think it was, can't see what the date was, I think I put it in yesterday, through to March this year. So that forecast service initially was set up for reef managers, but then as demand grew in the marine space, we'd also had some marine heat waves, fisheries and other stakeholders were also interested, which was the motivation for expanding it around Australia. So the way that we supported reef management in particular, because they're one of our most important stakeholders, is these outlooks have been presented at a pre-summer workshop for the last 15 years. So the Bureau presents, or we present our outlook. NOAA Coral Reef Watch also present their outlook. And if the forecasts agree, which most of the time they do, then the agency and all the other stakeholders, so there are tourist operators, fisheries, there is research bodies, so AIMS are there, JCU, for example, and also the Marine Park Authority, make their plans for what they're going to do that summer. So if it looks like it's going to be pretty boring, everyone can go and book their Christmas holidays, great. But if it's looking like it's going to be hot, then because the reef is so big and resources need to be well organised and managed, then plans are made about which areas we're going to target. Then if there is a mass coral bleaching event, so we've had 4 in the last 7 years. You can see the maps for 3 of them here. The 2022 one hasn't been formally released yet. The red dots are where this most severe bleaching happened. And so you can see different parts of the reef have been hit with these different events. So if one of these events happens, the chief scientist from the Marine Park Authority stands up a scientific advisory group. So there were 6 of us on that from different institutions, and we would meet weekly and provide information around current conditions and also what was projected, as well as information around what was driving the current conditions on the reef. So what was the Madden-Julian Oscillation doing, for example? What had been cloudiness recently? People had in-water observations as well. So it allows time to relocate resources for monitoring. At this stage, there is nothing they can do to stop the bleaching. There are some, on occasion, areas can be closed off to reduce, tourist stress, for example, in particular areas. But there is no solution to stop the bleaching, but it's around understanding it, getting the public involved. The minister always wants to know what's going on. Tourist operators want to know what's going on. It provides, as I said, $6.5 billion to the Australian community. So it's in everyone's best interest to manage it well. Picking up the thermal stress forecast. So these were a new forecast product that were developed with the reef in mind. So they were originally adapted from degree heating weeks. So what is important in terms of coral bleaching is the severity of the bleaching, so how much warmer it is than normal, and how long that persists. There's usually around a lag of a month between this onset of high water temperatures and actual bleaching that can be visible. And so that's where these degree heating month products came from. So they're an accumulation of an SST anomaly. So, but rather than using your seasonal climatology, so, January anomalies calculated against a January climatology, we take a maximum monthly mean. So the idea is that corals are pretty happy in a normal summer. If it's just an average summer, they're fine. And so we take that, the warmest climatological month. So on the Great Barrier Reef, that's usually around February. That's usually the hottest month. It varies on the West Coast. That can be December or April, depending on where you're looking. And we use that as our baseline. And then we accumulate it over 3 months. So the indicator of thermal stress, and there's been lots of work matching that up with bleaching observations, but it's very much a coral specific metric. And that was developed because of a customer demand and high profile customer demand. So what happens though? So then the question became, what happens on sub-monthly scales? Because this is all jammed together in 3 months, right? So it accumulates over lead if you're looking at a forecast. And so what is going on in between? And so this is following the Hobday paper in 2016 around marine heat waves. It's like, well, can we be getting more information around heat stress accumulation in the marine system? And there are plenty of other industries, particularly after the Tasman Sea marine heat wave in 2016, which impacted salmon. Other sectors are interested as well. And taking that, the other application for marine heat waves is that it can be used year round. So it really depends on the species you're looking at. Maybe it's really important, marine heat waves maybe have the biggest effect in winter because that's when your recruitment of your species happens, for example. So it just provides more applicability than the degree heating month product. So that led to a 4-year project with CSIRO. So that was myself, Grant Smith, Alistair Hobday, and Jason Hartog. And it was around developing marine heatwave products using AccessS. And so now we've got prototype seasonal marine heatwave forecasts running in trial mode. So when I say trial mode, that means they're not publicly available and they're not operational yet. So once they're operational, that's like your weather forecast. It's run every day. The Bureau supports it. It's publicly available. So we've been running them in trial mode and testing them with a select group of users. So we use them for our reef briefings when we do them. We've used them for recent fisheries briefings to get customers and users thinking about marine heat waves and what a forecast might look like, and building the interest and the demand for that product. So in terms of AccessS2, we don't use the daily forecasts at the moment. They're too noisy and it's a bit complicated. We haven't worked out yet how to do that with the ensemble forecasts. So what we've started initially is using fortnightly and monthly averages and working out the 90th percentile based on those and providing a forecast product in that way. So you can see this one here on the right is the latest forecast, well, from a few days ago for October. And you can see, for example, Tasmania lighting up. So if you're interested in more about the research and the products that we developed, this is a very long link, but I'll point you to this particular page here, which talks more about the project. So that research has been going on in the background, and we knew there were users out there and we had been using them in different briefings as they came along. But then a really big project came into being, I think it was last year, and this was driven by all the R&D corporations in Australia. They put together the agricultural ones, which includes fisheries, had got together under this umbrella company called the Agriculture Innovation Australia. And they wanted to invest from each of these different sectors in Australia into climate research and develop new products that would benefit those particular sectors. And the main focus was to have useful, usable, and used forecast products. So lots existed. Some sectors didn't understand them or didn't even know they existed. Others were like, yeah, that's great, but we want to get down into the weeds and really refine them. So it depended on which sector we were talking to. So Fisheries Research and Development Corporation were an investor. And we did 50 customer interviews with different sectors and groups of users from around the country. The challenge with fisheries is not like, say, grains, where people, grow a handful of crops, they're all in a particular region, they all have a particular concern. If we're talking to fisheries, we're talking everything from aquaculture, estuarine fisheries, coastal fisheries, offshore fisheries. They all operate different times of the year. They all operate different they all target different species. And so it's a really diverse portfolio. And also people have lots of different concerns and needs, and also agility as well. So, however, in talking to all these customers on the sub-seasonal to seasonal timescales, marine heat waves came out as one of the top priorities. and particularly due to recent events as well. It's very hard, for example, we always say without, I guess, if there has been a recent disaster, people are going to be thinking about it, right? So bushfires are a good example. There was a lot more funding being poured into bushfires because there's been a huge event in recent times. There'd been no fires, people would be looking at something else. So having had marine heat waves in recent memory for all the users, they're like, yeah, oh yeah, do you remember how bad that was? That was bad. If we know about that ahead of time, yeah, we would have done things differently. So the other part of this project as well is working with decision support to increase engagement in fisheries, because the agricultural sector, I'm talking sort of grains or cotton, they are way ahead of the game. Livestock, they've been using seasonal forecasts for 20 years. But the marine sector, because it's diverse, well, there's one reason, it's been a bit slower, I guess, to come to the table. So we want people to use the forecast we've got already and then build on that. So this project, we've put a proposal to FRDC, the Fisheries R&D Corporation, to operationalise the marine heatwave project. So we're currently waiting on the decision now for that to happen. So once, hopefully, we get the go-ahead, and then the idea is to operationalise those, make them public in the next 6 months. So that's really exciting. So we're just, everyone cross your fingers for us. So when it comes to decision support for marine heat waves, so there's different, this comes from a paper we published a couple of years ago. There's different components. I need to move my computer so I can see my screen. There's different, I guess, stages of an event. So what's the likelihood? This is your preparation window. This is what a forecast gives you. If you have an idea that a marine heat wave is coming, you're not preparing for anything. You can prepare for the worst case scenario, but that costs money. Do you want to do that every summer if you don't know there's going to be a marine heat wave? In some sectors, that's what they do. They're like, we're just going to plan for the worst case scenario, because if it does happen, it's really, really bad and this money is not wasted. But it depends on the sector and what their concerns are. They want to know when it's going to happen and how bad is it going to be. When will it peak? And so even once the marine heat wave's underway, the forecast can still give you information around how that event will evolve, when it will peak, when you're on the downward slide out of the event. So when will it peak? As we've called it your reaction window. When will it end? Okay, the worst is over. We're still in marine heat wave conditions. It's still hot, but we can see the light at the end of the tunnel. And the other piece of really useful information is, when are we going to get hit again? Okay, so we survived this marine heat wave, but they're happening more often. Then do we have resilience in our system, in our ecosystem, in our supply chains, in our coastal community to be able to cope with another event? And when is that going to happen? So that's really important to know when the next event is likely to happen. This is a screenshot from a recent paper in Nature led by Alistair Hobday, and it was around what are some of the things can we do. So at the moment, we're delivering national briefings to the fisheries sector. We've got one coming up in December. We've had 2 already. And people are asking, okay, so what can we do? How can we get together? How can we coordinate things? And that's involving extension officers, regulators, supply chain people taking the product to market, as well as the actual farmers or fishers. And so this just shows a few different steps here. When the event has happened, when it's underway, it's like, well, what can we be doing? At this point here, you're thinking about, what are my responses going to be? Then once you forecast, you've got closer to the event, you've got greater certainty that it's going to happen, you start adjusting to cope. And then that depends on how bad the event is. Then it's also evaluating the impacts afterwards. So what did that marine heat wave, what impact did it have? What did it impact on our prices that we went to market, because the fish were stressed because of the heat? Did we get coral bleaching? Where did it happen? How did that evolve over time? And then it's about resetting the system and the industry in preparation for the next event. All right, I will zoom through this because I'm conscious of the time. So coastal hazards, so shifting gears. So this is around, we're looking at total water levels. So high water levels, and it's a combination of factors that are driving that high water level. So the question came to us, can we predict high water level on a sub-seasonal to seasonal timescales, incorporating all these different processes? So things like sea level rise, tides, storm surge. Some of these yes, some of these no. So the project driving this is the Australian Climate Service. So this is a really big project. It's covering lots of different hazards. And the idea is to improve Australian community resilience to climate change into the future. So the main customers at the moment are emergency management and also the National Climate Risk Assessment. So ACS, the Australian Climate Service, everything from sort of short time scale, seasonal stuff, out to climate projections. And so our particular, or the part I'm involved in is around the coastal hazards and are looking at the seasonal, what can we do in the seasonal space? So this is just a nice slide summarising the ACS. And so it's about considering the climate situation, so whether it's marine, whether it's fire, whether it's flood, those hazards, so the actual environmental hazards, over time and space and how they will change with time. And then there are other components of the Australian Climate Service then looking at vulnerability and exposure to those hazards and therefore the impact. We're developing a seasonal sea level forecast system. So that is taking sea level out of Access S2, combining that with tidal predictions, combined with regional long-term trends. That work's coming out of CSIRO, sea level rise estimates. So it's been going on for a few years and we're leveraging that in the Pacific. So COSPAC, which is I never remember the full acronym, but they've been developing seasonal sea level outlooks. Just anomalies though, straight out of the model. So part of our work was to work out, what does that mean? If we have an anomaly of this many centimetres, for example, what does that mean at the tide gauge or at the coast? How do we transform that into a total water level? And we also have multimodal forecasts that have been running sort of in trial mode with the University of Hawaii Sea Level Centre. There's an example there on the right for a Pacific island. We also provide information to Defence via the Global Seasonal Outlook. They want to know, particularly for Pacific Islands, given the Defence are involved in a lot of humanitarian aid, is there a chance of higher sea levels in particular regions? So the questions for us, work has been going for sort of probably 6 months in earnest, is research questions like, how do we combine this data? It's all different spatial scales. If we're going to produce an operational product, we need to have all that data together. And then how do we reconcile all the different datums and reference points? Tide gauge is this, the harbour is this, our model comes out of another particular baseline. So they're questions that we've got. I've got about 3 slides left. I'll whiz through them. So what, we're going to develop a service, right? So we're going to put it all together so that people understand, they know where to get their information from. So we've got a historical context. What does it look like in the past? What has the risk been? What are the places that have flooded in the past? Then we have our outlook. So people can plan for the upcoming months. And then that then joins to or combines to projections. So this is for around town planning and councils and, informs government policy about what's going to happen in the future. These areas that have never flooded, likely to flood in the future. So it's about putting all that information together, and it will be tailored depending on who we're talking to. So whether it's emergency management, whether it's climate risk assessment, whether it's general public, whether it's defence. So it's a really big challenge. It's super interesting. There's a lot of moving parts in it. So taking the hazards, this combination. So the hazards that we're talking about, marine heat waves, coastal sea level, that is the environmental hazard that we're looking at. But there are other factors over the top of that. So there's exposure. So that is the things that are exposed to the hazard. So, it's your salmon farm sitting in the middle of a marine heat wave, for example, or your coral reef. Then you've also got your vulnerability. So how they can respond. And this is part of where seasonal forecasts fit in. So they come under this adaptive capacity. Can I change things to respond, to mitigate the impacts of the hazard? And then this all ends up with your impact year, the combination of those three things. It also depends on your agility. This is a paper led by Jason Hartog. These are different levers, for example, in marine industries. So how they respond will depend on these different levers. So if it's a tightly regulated system, maybe they can't actually do much. Aquaculture are heavily manipulated. They will have a lot more strategies at their disposal to minimise the impacts of marine heatwave than a wild commercial fishery. And lastly, to wrap up, looking to the future. So ocean extremes are predicted to increase under climate change. Subseasonal to seasonal forecasts can provide advanced warning of these hazards and allow people to adapt to better cope with the conditions. And one really interesting question that we've discussed over the years in this space is like, does thinking about the short term help people think about the long term? I can't operate the way I always have because things are changing. So does that get people thinking about, we've never had a season like this before. Things are changing. So I think that's a really interesting question. I'll skip this one, but I can talk about it if anyone's interested. This is the outlook for this summer, looking really hot. We're running lots of briefings at the moment for various different stakeholders, and that's it. So if you're interested in any of the national briefings, there's a couple of links. These ones are to fisheries, and if you're interested in the papers, underpinning this research, I'll point you to that link, and I will stop talking. Thank you, everyone.
Thanks very much, Claire. That's a really fantastic talk. I really enjoyed it. Now we are open for the questions. You can either put your hands up for a question or put your question in the chat box. Yes, Craig, go ahead.
Hi, Claire. Thanks so much. Really interesting. I was wondering if the Bureau has any interest in trying to create, attached to the S2S ocean forecasting system, also a prediction system for, I don't know, ocean biology. So I'm just sort of thinking like I guess in principle, given that the temperature, what's been going on with the nutrients, actually maybe you don't know what's been going on with the nutrients, but in principle, you could try and predict temperature and nutrients, and then you could have a go at predicting about sort of what range of fish species could be thriving in various areas. And so to be actually predicting the things that I guess the fishermen care about so much, of the fish stock, basically. Is there a plan to do something like that?
No, not from the Bureau side, but I guess over the last 10 years, we've partnered with CSIRO. So they tend to do the biological aspect. We provide the climate information. So we've done habitat distribution models for southern bluefin tuna, for example, where we've combined like temperature preferences with, it's a proxy, right? For chlorophyll, for example, where the tuna are going to be found. We've got an example at the moment. There's the Maugean skate, which is an endangered ray down in Tasmania, and there's a task force being put together to look at how that's affected, or how it's going to go in the upcoming summer and then in the future. Right. So we provide we're looking at trying to provide the climate information and then nest that on the seasonal output, nest that with fine scale estuarine models, which do have that biogeochemical part of it as well. The Bureau is never going to run a BGC model as far as I'm aware. That was my past life. So obviously I would love them to, but that's really what CSIRO contributes to those kind of projects. But there's definitely a demand for it. And that's where that partnership comes in, or with universities as well, if, that's part of the project.
Okay, thank you.
Thanks, Claire. I do have some questions by myself. So the first question is, do you have any comments on the marine heat waves around Australia this summer? Because the El Nino and the positivity just been declared by Bureau of Methodology as officially comes. So do you have any comments on that?
Yes, so that was that slide I zoomed over because I was running out of time. So yes, we've had the National Fisheries briefings. The Marine Parks Authority are already asking us. We've got DEQ, which is Department of Environment, already asking us about what's going to happen this summer. So the El Nino and the positive IOD underway. So that those combined, if you're on land, warm, dry conditions. So farmers in particular are concerned about that. Anyone who operates in the estuarine sort of zone. But our forecasts are showing high likelihood of marine heatwave conditions off Tasmania and Victoria. So you can see the sea surface temperature plots out to March on the right. And then these are a bit small, but down the bottom, this is October, November. And yeah, you can see this is an ensemble mean too. So if we look at the probabilities, these are around 80 to 100% of forecasts are indicating above the 90th percentile off the east coast of Tasmania and through Bass Strait. So, and that's looking to persist. And you can see here in the sea surface temperature forecast, you know, these anomalies are 2.5 degrees above the February climatology. So really warm. Yeah, so when the Bureau announced the El Nino a couple of weeks ago, it was a whole flurry of briefings. So ministerial ones, Senate estimates. Yeah, so it is I mean, it's only the start of October. If we're trying to forecast February, March, the model doesn't have great skill that far out, depending on where we're looking. And so, for example, the pre-summer workshop for the reef is end last week of November. So, and then we'll update them as the summer progresses. There's a high interest around it at the moment because of that. Yeah.
Great, thank you. Is there any other questions online? Yeah, Neil, you can unmute yourself. Short one,
can you
please.
see me?
Short one.
Yeah, it's probably a question. Thanks, Claire, for a great talk as usual. It's probably a question that'll probably go way over time. My question won't be, but probably the answer will be. Have you got any comment to make about overall about stakeholder uptake of, you know, the kinds of things that you do? So, you know, you put out seasonal forecasts and so on, and fishers respond. So, you know, what sort of uptake? I mean, I know you've got a lot of comments around, you know, the hard work you have to do to get stakeholders to uptake, you know, forecasts and so on. But, you know, have you got any overall comment to make about uptake, and what does success look like in that context?
Over the years, there have been small sector-specific sort of projects, and we've been, I guess this summer has been the first time we've had FRDC and a national demand. Given we're the Bureau, we have to serve the Australian public. We don't want to keep doing these little piecemeal, bespoke forecast products for a particular industry. We want to do something national that will serve most of the population. So it's been building up that trust, that reputation over the last 10 years. And some you know, didn't work that well. They're like, nah, we don't really need it. We're just going to, you know, manage it like going to be hot every year, you know, whatever. Whereas others, industry themselves have said, oh, we want more. Can we pay? We will pay out of our own pocket, our own shareholders. It's not coming from a government agency. And so that's a real sign of success, that they're happy to allocate their resources, particularly for small sectors. They're like, no, we want this information. Whereas I think this year, we had FRDC come to us and say, all right, we want you to give us a national, we want this. And so then it's not just our team driving it. It is the sector who are demanding it and wanting it. And then it's a bit like, you know, this person over here is using the, you know, the other guy across the fence or across the pond is going, well, how come they get jump on me commercially? They got information that I don't have or I don't know about. And so then it's real organic grassroots growth and uptake. But you need the trusted people in the community or in the sector to be saying, this stuff, you guys want this stuff. You want to have this forecast information. And that's when I feel like we've got critical momentum now. If we can't get these marine heatwave forecasts operationalized this summer, we're never going to, right? So yeah, it's been a case of building up, and that's what success looks like. It's people going, oh, you guys know what you're talking about. Give us more. We want more. Come and talk to us. Come and tell us about it. And then they take that and go and talk to their stakeholders. So it's about building that capacity as well, I think. And yeah, having that momentum. And like I said, a good disaster focuses the mind. People are like, I don't want that to happen again. We can't handle another summer like that. So give us all your tools, all your information. Someone come talk to us in the language we need, because we can't cope with another season like that. So I think it's a combination of lots of different things. But definitely this year, the announcement of the El Nino, people also El Nino hot everywhere, which is not the case, right? There's a nuance to impacts around Australia, but it gets people thinking about it. And they go, oh, remember 2016? We don't want that again. So that's the semi-short version. Neil.
Thanks. We'll have the long version over a cup of coffee. See ya. Thanks a lot.
We could do that.
Thanks very much, Claire and Neil. I think we'll wrap up here, given this ECR session, following ECR session. Thank you very much again, Claire, for this fantastic talk. And thanks everyone for joining today. I'll see you next month.
Pleasure.
See ya.